Okay, let's talk about which way is positive and which way is negative. You might be tempted to say that to the right is positive. Well, then that's that way, right? No. You're probably looking at me funny because your right is that way. So because we're facing each other, using right and left is not going to work great. So let's just say that that way is positive. Does that work? I think so. Doesn't matter. You get to decide which way is positive and which way is negative. So let's just say that that way is positive and that way is negative. Okay, acceleration versus time graphs. On our horizontal axis, we are going to have time. So to the right is the positive direction. As you move along the horizontal axis, time is passing. On the vertical axis, we have acceleration. A for acceleration. We're going to call this direction positive and this direction negative. This point here is 0. This is where time is 0 and acceleration is 0. But this entire horizontal axis represents where the acceleration is 0. So if our graph is touching this horizontal axis, our acceleration is 0. Anything above the horizontal axis on this half of the graph is going to have a positive acceleration, and anything on this half of the graph below the horizontal axis is a negative acceleration. Now remember, acceleration is a change in speed or a change in direction. So when you're approaching drawing an acceleration versus time graph, the first thing that you need to determine is whether the object is accelerating. Does the object have an acceleration? How do you find that out? First, you ask yourself, is the object changing speed? Then you ask yourself, is the object changing direction? If the answer to either of those questions is yes, then the object has an acceleration. If the answer was no to both of those questions, then the object has 0 acceleration. Okay, now let's watch some videos and then draw some acceleration versus time graphs from them. Okay, first we need to determine, were the objects accelerating in those 3 videos? So first you think, does the object change speed? Well, in all 3 of those videos, the person was standing still the entire time. So no, they didn't change speed. Then we ask, did the object change direction? Again, in these videos, the object stayed in the same place the whole time. They didn't change their speed, they didn't change their direction, so they had a 0 acceleration the entire time. So how do we represent 0 acceleration on an acceleration versus time graph? Well, we start at t equals 0 at the very beginning. Then we say, okay, what's our acceleration at t equals 0? It's 0. We already decided that. And as time passes, the acceleration is still 0 because the object never changes its speed and never changes its direction. So for all 3 of those videos, because the acceleration was 0 the whole time, your graph is going to look like a flat horizontal line on the horizontal axis. And the acceleration is 0 the entire time. Okay. In these 2 videos, we're drawing an acceleration versus time graph. So what we need to determine, is the object accelerating? First step, did the object change its speed? Well, in both of those videos, the object was moving at a constant speed. Constant speed means the speed was not changing. So no, the speed was not changing. Was the direction changing in either of those videos? No, the person was moving in a straight line the whole time in the same direction. So the person didn't change their speed, didn't change their direction, they had a 0 acceleration. So guess what? Our graph is going to look the same as for the previous 2 videos. So at t equals 0, at the beginning, the acceleration is 0, and as time passes, the acceleration is still 0, and it's always 0 because the object never changes its speed or its direction. In these 2 videos, Yes, the object was moving with a faster speed in these two videos, but was the speed changing? No, the speed was not changing, and neither was the direction. So again, the acceleration is going to be 0, and our graph is again going to look like this flat horizontal line along this axis at a equals 0. So what's interesting is that the motion in all 6 of those videos, or whatever, was different, right? They were moving at different speeds in different directions, but the graph for each one of them was exactly the same. And that's because they all have one thing in common, and that is that they have 0 acceleration. And because we're drawing an acceleration versus time graph, we care only about the acceleration, and it is 0 for all of those videos. So if you have a horizontal line at 0, it represents 0 acceleration. So an acceleration versus time graph at 0 means 0 acceleration. From this graph, can you tell whether the object is moving or at rest? No, you can't, because if an object is moving at a constant speed, it has 0 acceleration, and if an object is at rest or not moving, it also has 0 acceleration. So this graph, where acceleration equals 0, does not tell you whether an object is at rest or moving at a constant speed. So this graph could mean either at rest or moving at a constant speed. The acceleration versus time graph will look the same for an object at rest or an object moving at a constant speed. It doesn't matter how fast or slow that speed is. If it's constant, our acceleration versus time graph will look like this. For AP Physics 1, for all of the acceleration versus time graphs that you're going to see, that you're only going to be drawing flat horizontal lines. So you're not going to have any diagonal or curvy, swervy lines. Okay, in that video, was the object accelerating? So first we ask, did the speed change? Well, at the beginning, the object was stopped, and then it started going faster and faster and faster. So yes, the speed was changing. So that means that the object was accelerating. So we do have an acceleration in this case. So if we've decided that the object has an acceleration, our next step is to determine whether the acceleration is positive or negative, whether our graph is going to be on the top half or whether we're going to draw the graph on this half, on the bottom half. Positive, negative. Now this is a tricky thing to do. So in the video we decided the positive and the negative direction. So to determine the direction of acceleration, to determine whether the acceleration is positive or negative, you have to look at two things. In which direction is the person moving, and are they speeding up or slowing down? You have to consider both of those things. First, we look at which direction the object is moving in. Dun dun dun! This is important. Be careful. The direction that the object is moving is not always the same direction as the acceleration. The direction the object is moving helps to determine the direction of the acceleration, but it's not the only thing that determines the direction of the acceleration. In this video, the person is moving in the positive direction. But wait, just because it's moving in a positive direction doesn't automatically mean that the acceleration is positive. Now the second thing that we have to look at, are they speeding up or slowing down? The person is speeding up. If the person is speeding up and they are moving in the positive direction, that means that we have a positive acceleration. So we're going to be on the top half of the graph, which represents positive acceleration, and I'm going to start somewhere here. And as time passes, the acceleration is constant, so our graph is going to look like this. So a positive acceleration can mean speeding up in positive direction. So if you see a positive acceleration, that could mean that the object is speeding up in the positive direction. It can also mean something else, but we'll come back to that. Okay, in this video, was the object accelerating? Did the speed change? The object started at rest from a stop and then started going faster and faster. So the speed was increasing, the speed was changing. So yes, we have an acceleration. Now, we need to determine, is the acceleration positive or negative? Where do we draw our graph? We look at in which direction was the person moving. The person's moving in the negative direction in this case. Just because they're moving in the negative direction doesn't always mean they have a negative acceleration. You know which direction the person's moving in. Now you got to decide, well, is the person speeding up or slowing down? Is their speed getting bigger or smaller? Well, the person is speeding up. They are getting faster. So this person is speeding up in the negative direction. If an object is speeding up in the negative direction, their speed is getting more and more negative, and their acceleration is going to be negative. So our graph, as time passes, the acceleration is a constant negative acceleration. If you see a negative acceleration, that can mean that the object is speeding up in the negative direction. Okay, it can also mean something else. We'll get back to that later. Was the object accelerating? Well, the person was running really fast and then they slowed down to a stop. So their speed decreased. So their speed changed, and yes, we have an acceleration. Now we got to decide, is it positive or is it negative? Which direction was the person moving? The person was moving in the negative direction. Now, next question, are they slowing down or speeding up? The person is slowing down. They are slowing down in the negative direction. If the person is
slowing down in the negative direction,
their acceleration is positive. So the acceleration versus time graph for this is going to look exactly the same as a couple videos ago because we have a positive acceleration. A positive acceleration can also mean slowing down in the negative direction. So a positive acceleration can mean one of two things. The object is speeding up in the positive direction or slowing down in the negative direction. In this video, do we have an acceleration? Did the object's speed change? Yes. The object started moving fast and it slowed to a stop. Now we got to decide, is it positive or is it negative? To decide that, we ask, which direction is the person moving? The person is moving in the positive direction in this case. Then we think, okay, is the person speeding up or slowing down? In this video, the person is slowing down. Their speed is decreasing. If an object is slowing down in the positive direction, then they have a negative acceleration. And so our graph is going to look the same as a couple videos ago. Flat horizontal line, negative acceleration, because the person is slowing down in positive direction. So they're moving in the positive direction, but they're slowing down. That's why they have a negative acceleration. So a negative acceleration can mean one of two things. It can either mean that the object is speeding up in the negative direction or slowing down in the positive direction. When you ask yourself in which direction the person is moving, if you say, ooh, the person's moving in the positive direction, that must mean the acceleration is positive. No, not necessarily. It depends also on whether they're speeding up or slowing down. Because if they're moving in the positive direction and speeding up, they have a positive acceleration. But if they're moving in the positive direction and they're slowing down, then they have a negative acceleration. Alright, in this video, did the person accelerate? So first, did their speed change? Well, yes, they were moving fast, then they slowed to a stop, and then they sped up again, but in the opposite direction. Did their direction change? Yeah, first they were moving in a positive direction, they slowed to a stop, turned around. Turning around means they changed their direction, and they start speeding up again back in the opposite direction. So we have a speed change and a direction change. So we definitely have an acceleration. Is the acceleration positive? Is it negative? Does it change maybe? Well, no. The acceleration is still constant. Here's why. Let's draw this graph. To make it easier, when we're thinking about it, let's split it up into two parts. The part where the person's moving in the positive direction, and then the part where the person's moving in the negative direction. So at the beginning, in which direction is the person moving? The person is moving in the positive direction. Is the person slowing down or speeding up? The person is slowing down. So at the beginning, they're moving in the positive direction and they're slowing down. Based on our previous graphs, we know that that means a negative acceleration. The person is slowing down in the positive direction. So we can start with our graph here. So I'm just going to draw like half, like a little part of it. I'm not done. When the person comes to a stop, does that mean that they have zero acceleration?
Well, no.
Because the person's not stopped forever. They stop for a split second. They're moving in the positive direction and they stop for a split second so they can turn back around and go in the opposite direction. And so they have to stop for a split second to change direction, and that change in direction is an acceleration.
So even when they're stopped for a split second, they still have an acceleration then.
So during this entire time, the object has an acceleration. The speed is constantly changing and the direction changes. So we've determined that when they come to a stop, they still have an acceleration. So when they turn around, they still have an acceleration. They're always accelerating.
Because their speed's constantly changing.
So when they turn around, is our acceleration still negative or did it switch to being positive? I don't know. Let's figure out in which direction that acceleration is. So once they turn around, they're now moving in the negative direction. Okay, is the person speeding up or slowing down? After they turn around, they start speeding up in the negative direction. So we know that speeding up in the negative direction means a negative acceleration. So actually, the person has the same negative acceleration the whole time. And that's one of the trickier videos. But the person changes speed, changes direction, but they have the same acceleration the whole entire time. And if you look at what we wrote earlier, you get a negative acceleration the whole time. First, they were slowing down in the positive direction, they turned around and started speeding up in the negative direction, so you get that negative acceleration. I want to address what an acceleration versus time graph will look like if you have an acceleration that changes. So in the previous graphs, we had all those flat horizontal lines, and I wasn't lying when I said acceleration versus time graphs for AP Physics 1 are going to be horizontal flat lines. But sometimes as time passes, the acceleration can abruptly change. And so I just want to show you what that's going to look like on a graph. So let's say that an object has a positive acceleration, and then all of a sudden they have a negative acceleration. What does that look like on a graph? You're not going to have any diagonal curvy lines. What it's going to look like, it's going to look like a staircase or like steps. You're going to have a vertical line down, and now your object has a negative acceleration. So it has a positive acceleration, flat horizontal line on the positive side of the graph. If that acceleration suddenly becomes negative, so you draw a vertical line straight down to the negative side of the graph, and then again you're going to have this horizontal line for a negative acceleration. And so if acceleration's changing, it's just going to look like stair steps. So if the object has a negative acceleration, what if then it stops accelerating? So it, I don't know, maybe it starts going at a constant speed.
Well, if it stops accelerating, the acceleration is going to be 0. So we somehow need to get to the 0 line. And for acceleration versus time graphs, we would draw a vertical line to where we want to be. And then if the object is moving with 0 acceleration, as time passes, you would get your line like that. So that's a positive acceleration, that's a negative acceleration, and this is 0 acceleration. When the acceleration changes, you just drop straight down or go straight up and draw your new acceleration.